Let's take a look at how to solve a quadratic equation in standard form by graphing. We have 0 equals x squared plus 2x minus 3. We're looking for the value or values of x that make this equation true, and it turns out if we plug in -3, the equation works, and also if we plug in 1, the equation works. Well, let's take a look at why that works if we look at graphing the equivalent function. The equivalent function is written by replacing 0 with y. We're going to go ahead and graph this y equals x squared plus 2x minus 3 by finding the axis of symmetry and the vertex just the way we'd graph any quadratic function to get a parabola. So we see our axis of symmetry is x equals -1. The vertex is -1, -4. We're going to use that to then create a graph, and we're going to see how the graph relates to solving the original equation. We have our axis of symmetry, put our vertex on there. Now we know the value of c is the y-intercept, so we have another point we can put on the graph very easily, 0, -3. Now with a table of values, we'll go ahead and find a few other x values, and let's look to the right of the axis of symmetry and get those ordered pairs, plot them, and then reflect them onto the other side. So we see 1, 0, and 2, 5. We reflect those and we draw our parabola. Once we draw this parabola, what we're looking for, where does it intersect the x-axis? Because where it intersects the x-axis, that has a value of 0. So we see that the parabola intersects the x-axis at 1 and at -3. These are the zeros of the function. The zeros of the function are the values of x you put in to get a value of 0 for y. That's why they're called the zeros. They make the function give you 0. Turns out the x-intercepts are where the value of y is 0. What if we have this one? 0 equals -2x squared plus x plus 3. Once again, we want to look at the equivalent function. Oh, gosh, what if it's not in standard form? Well, solve the equation for 0 first. Of course, we want 0 equals ax squared plus bx plus c. Well, we have that. So y equals -2x squared plus x plus 3. That's the equivalent function. We're looking for when does x make y 0. As always, we start with the values of a, b, and c. So we can find our axis of symmetry, x equals -b over 2a. This gives us x equals 1/4. Ooh, this is going to be a little bit of a messier graph. So the axis of symmetry, x equals 1/4. To find the vertex, we use the x value of the axis of symmetry, plug that into the equation. Now we do a little bit of arithmetic. Once we do a little bit of arithmetic, we find the y value for the vertex. Turns out the y value for this vertex is 3 1/8. So our vertex is 1/4, 3 1/8. Well, not the easiest numbers to graph, but we'll get there. Now we're going to do a table of values to get a couple ordered pairs to the right and then a couple ordered pairs to the left. If we plug in 1, we get 2. If we plug in 2, we get -3. So those are 2 ordered pairs on the right of the axis of symmetry. Now let's look for 2 ordered pairs on the left of the axis of symmetry. Well, if x is 0, that's our y-intercept. The y-intercept is always the c value when we have this thing written in standard form. So we have 0, 3. If we go another unit to the left, we plug in -1. We plug in -1 and we get 0. Oh, that's interesting. Keep that in mind. We plug in -2. We plug in -2 and we get -7. So now we have our vertex, the axis of symmetry, 2 ordered pairs on either side. So let's make that graph. 1/4, 3 1/8. You don't have to get exact, of course, just get close enough. Yeah, that's pretty good. And then, well, we have 1, 2. We have 2, -3. That's good because we want values on either side of the x-axis so we can see where it intercepts it. Now we know our y-intercept is 3, so we plot that ordered pair. And then we get to -1, 0 and -2, -7. That's interesting. -1, 0. If we plug in -1 for x, we get 0 for y. That's kind of what we're looking for. So we actually have one of those x-intercepts. We have one of those values of x that make y 0. So we look for the x-intercepts of this function, which will be the zeros of the function, which will help us solve the original equation. So this one, well, let's see. It isn't exactly at an integer, so it looks to be about 1.5 comma 0. So it looks like the solution, the x-intercept, the 0, is 1.5. How do we know for sure? Well, we will go to the original function, plug in 1.5, and see if we get 0 as a result. If we get 0 as a result, that's the 0 of the function. And that means 1.5 for x would make the original equation true, because we'd have 0 equals 0. Yep, we get 0. So that is one of the roots, one of the zeros of the function. So we have -1 and we have 1.5. Now let's take a look at some of the vocabulary. I've been using a few words interchangeably here. So the first word we want to look at is 0. That's the input of a function that returns an output of 0. I've also been using the term x-intercept because the x-intercept is where the graph intersects the x-axis and the value of y is always 0 where that happens. Root is another word for 0. So sometimes you'll hear the root of a function. That's an input value that gives you an output value of 0. So whether we use the term 0 or root, we're talking about the same thing. Well, if I have 0 equals x squared plus 2x minus 4, I'm going to go through the same process. I turn it into the equivalent function y equals, I find a, b, and c, so I can go ahead and get the axis of symmetry. The axis of symmetry for this one is x equals -1. That gives me a vertex of -1 comma -5. So since I have an integer value for the vertex, I'm just going to look at integer values to one side of the axis and then reflect them on the other side to get a nice, neat parabola. So at -1, I know I have an output of -5. That's the vertex. I also know the y-intercept is -4 because the value of c, when in standard form, gives me the y-intercept. Keep going in the other direction. If I plug in 1, then my output value is -1. And let's get one more on that side of the parabola. And I plug in the number 2, and I get an output of 4. This gives me enough to get my graph going. So I have my axis of symmetry, my vertex. I've got 3 ordered pairs on one side. I can reflect them to the other side of the parabola. There's the axis of symmetry. The 0, -4 is the y-intercept. Then I have 2, 4, and I'm just reflecting these points on the other side, same distance on either side of the axis of symmetry. Draw this parabola really carefully and take a little bit of a closer look here. And this is going to be a little bit more difficult than the first two. I don't see that I have a nice integer intersection or even a rational number. So I see that my roots are somewhere on one side between -4 and -3, and on the other side somewhere between 1 and 2. So I'm going to kind of see if I can round to the nearest tenth. Turns out they're irrational numbers, and we'll see later how to find those irrational roots. But for right now, I want to get an approximation based on the graph. So if I'm looking at between 1 and 2, let me pick 1.3. That looks pretty close based on the graph. So I'm going to use a calculator here to speed up the calculations. Plug in 1.3 for x, go through the motions, and I get an output of 0.29. If I plug in 1.4, I'm going to get, do I really want 1.4? I'm going farther to the right, and the parabola keeps going up to the right, so I really should look to the left. So if I plug in 1.2, then I get an output of -0.16. So it's somewhere between 1.2 and 1.3. I'd probably go with 1.2 since the output is closer to 0, but it's somewhere between those two numbers. If I had to round it, I'd round to 1.2. Now we need to consider the other side. Where's the x-intercept on the other side of the parabola? It's going to be somewhere between -4 and -3. So I'm going to pick something pretty close. How about -3.1? So just like I did with the other ones, I'm going to plug in -3.1 into the equation, see what I get as an output. So if I plug in -3.1, square it, plus 2 times -3.1 minus 4, I get an output value of -0.59. So let me try -3.2. I got to keep going in the negative direction, so that parabola goes up. Oh, I get -0.16, so I got to keep going a little bit more. And if this one gives me a positive value, I know yep, it does. So I'm somewhere between -3.2 and -3.3. I want to use the one that's closest to 0, which is going to be -3.2. Now look very carefully. 1.2 is the root in the positive direction. On the other side, we have -3.2. These should be the same distance away from the axis of symmetry. Our zeros will be equally on each side of the axis of symmetry. And it turns out each one of these is 2.2 units on either side of the axis. So to solve a quadratic equation by graphing, we set 0 equals, we turn 0 into y, graph that related function.